Hello and welcome to this machine learning course. What's linear regression with one variable? Actually, to answer this question, we are going to need to know first of all, what is linear regression? Linear regression is a machine learning algorithm aimed to predict continuous values like height, price, or weight of anything. For example, we're gonna need, for example, to predict the price of houses in anywhere in any area. We're gonna need to predict the height of people, and with one variable, this means that we have one single feature to predict the price or the output based on it. For example, I want to predict the price of the house based on the number of rooms this house has, or I want to predict the height of a person based on where he lives. Of course, this is not a good feature, and this is about the parameter, the feature engineering and the feature engineering and data wrangling to be able to get to decide what is the best features for your algorithm, or actually for your model after training. So, for example, I want to tell if for example, I have, for example, zero point 0.4 of anything, what would be the result based on this model? To do this, we have something called the linear model, the linear regression, and this is based on the equation of the straight line, which is y equal mx plus c. Of course, if we have correlation between data, if you know have if you do have any machine learning background, you should know that in what we're doing actually is that have some scattered plot here, and we wanna draw a line that best describes them all the most. For example, this line best describes them. It's not, of course, it's not this, it's not anything else. This is the line that describes them the most. So, back to the linear equation, we're gonna need what can we change to modify this line? The x here is the input, which is I have 10 rooms in this house. What is the price? What should the price of the house be? And this, of course, cannot be changed because this is the input. The y is what I actually want to predict. In this case, it's the price. But the c, which is the y-intercept, and the m, which is the slope, this is what I can actually change. But for the sake of this machine learning course, we're gonna need to modify these names a little bit. We're gonna call the c as phi naught and the m as phi 1 for the sake of the machine learning algorithm. So, and to best find what is the phi naught and phi 1 are, actually what is the best phi naught and phi 1 are, we're gonna need something called the gradient descent. The gradient descent is a famous linear regression optimization technique, which we firstly we place our two phi's randomly anywhere in this descent. Of course, here is the optimal solution. Here is when I have the best model output. And once I place these the two phi's randomly here, I now want to modify them. And this is what actually every machine learning model does. It places them at first randomly, then it modifies them. To be able to modify them, I'm gonna need here this image calls it W, but we're gonna call it phi 1 or phi naught. Of course, this equation works for both. Equals phi old minus alpha, and with some partial differentiation for the cost function here, we're gonna find the new one. How's that possible? Well, actually, let's suppose that we have here the random phi at first. If the differentiation for the cost function is negative, then negative, the negative, which is positive, it's gonna be a positive number. So it's gonna be the old phi plus something. So it's gonna go forward. And going forward makes it go near this optimal solution. And what's the alpha? The alpha is the learning rate. It's the size of the step taken by the alpha each time. Here, this is the alpha. The alpha should not be very too high to avoid something called the overshooting, and should not be very low to not have a very slow model. But instead, it should be something in between. So it's gonna be the phi is gonna go here for the first time, and again by the same equation it's gonna find that it should go more, it's gonna increase. And of course the cost function is modifies every time, and we modify it every time to see what's the output of the new phi. Once the phi reaches here, it's not gonna stop because it does not know yet that this is the optimal solution. So what's it gonna do? It's gonna go forward again. But once it goes forward again, the cost function is gonna increase, not decrease, as when it was going down. And once the model finds that the cost function is increasing, it immediately knows that that the previous stage was the optimal solution. Doing this for the M and the C, or phi naught and phi 1, it gets the perfect parameters for our model. And by doing this, it gets to the optimal solution where the slope is 0. After it goes there, it comes with this perfect line. Of course, it's not 100% accurate, and we have some error. For example, for this, when we are at 0.2, the model should tell something between 2.6 and 2.7, but what it's actually gonna do, it's gonna tell over 3, and this is an error. This is not good, but this is the best we can find here. If you want to get something more accurate, then you should either use another algorithm, machine learning algorithm, or best of all, you should select more good data, which should have more correlation than that one. Thank you.